To draw the force diagram, we first draw a dotted circle around the object we're measuring, in this case the elevator. The upward force is the force of the pulley on the elevator, and the downward force is the force of the earth on the elevator. The sum of forces in the x direction is 0 newtons. The sum of forces in the y direction is the force of the pulley on the elevator plus the force of the earth on the elevator.
Heat radiation does not require matter. It is the transfer of energy through electromagnetic waves.
The chicken warmer is an example of electromagnetic radiation.
Heat is the kinetic energy of molecules. Newton's law of cooling states that the rate of cooling is related to the temperature difference between a system and its surroundings. The big T represents temperature, while the small t represents time.
The second law of thermodynamics is
entropy!
All things become more and more disordered unless some action is taken to keep them ordered. Natural processes go in a direction that maintain or decrease the order of the universe. This messy system has high entropy, while this organized system has low entropy. The entropy of this system is being increased.
Newton's first law states that in the absence of a net force, an object at rest will remain at rest, and an object in motion will remain in motion indefinitely in a straight line. For example, these apples are at rest. If I threw the apple through space, it would continue with constant velocity in a straight line path forever and ever and ever. However, if I rolled it across the ground, it would slow to a stop due to the force of friction acting in the opposite direction.
In this demonstration, two carts with different masses are colliding. They bounce off of each other with different velocities. This equation shows the momentum of each cart is conserved before and after the collision. When we plug in the values we know, we are able to find the final velocity of the 10 kilogram cart. The value is calculated to be 1.5 meter per second.
Gravitational potential energy, abbreviated as GPE, is energy stored by change in position. The formula for gravitational potential energy is mgh. M is mass in kilograms, g is the gravitational acceleration, which is 9.8 meters per second squared, and h is height in meters. Kinetic energy, abbreviated as Ke, has the formula 1/2 mv squared, where m stands for mass and v stands for velocity. Kinetic energy is energy in motion. In this scene, the cart's GPE is being turned into Ke as it rolls down the ramp. As explained previously, the formula for gravitational potential energy is mgh. Initially at the top of the ramp, the mass of the cart, 10 kilograms, the gravitational acceleration, 9.8 meters per second squared, and the height of the ramp, 5 meters, are multiplied together. When calculated, the energy is 490 joules. Also explained previously, the formula for kinetic energy is 1/2 mv squared. The energy is equal to 0 joules because the velocity is 0 meters per second at the top of the ramp. At the bottom of the ramp, the cart's GPE is equal to 0 joules because the height of the ramp is 0 meters. At the bottom of the ramp, all of the cart's gravitational potential energy has been converted into kinetic energy. We can use this energy to find the final velocity of the cart at the bottom of the ramp. When calculated, the velocity is found to be 9.9 meters per second.